the complement rule for independent events. Our objective, we want to compute the probability of an event happening using the complement rule. Let's remind ourselves the definition of probability: a measure of the likelihood of a random phenomenon or chance behavior occurring. So what is the complement of an event? Okay, the complement of an event is all outcomes that are not the event. They would be part of the complement. So when flipping a coin, if the event is heads, okay, the outcome that is not heads, the complement is tails. Okay, if rolling a die, we want an even number. Okay, that's the event. I want to roll an even number. The complement would be rolling an odd number, the numbers that are not even. Those are complements. For any event, either the event happens or it doesn't happen. Okay, back to our heads and tails. The event heads happens, or it doesn't happen, it lands on tails. Together, the event and its complement make up all possible outcomes. Okay, the event plus its complement equal 1. Mathematically, the probability of the event or the complement of the event, and this is the notation for the complement, E superscript C. Well, we know that OR probabilities are addition, so we're going to add the probability of the event plus the probability of the complement of the event. It's either one or the other. There's no overlap, and we're going to wind up with the number 1. Okay, everything is included. It's either going to be the event or it's not going to be the event, and the probability of those two things added together is all probabilities. Okay, so the complement rule plays off of that with a little bit of algebra. We're simply going to subtract probability of E from both sides, and that gives us the complement rule. If E represents the event and E superscript C represents the complement of the event, then the probability of the complement is 1 minus the probability of the event. Similarly, the probability of the event is 1 minus the probability of the complement of the event. We can work with both of those to come up with probabilities. Sometimes it's a shorter way to do things. Okay, so when do we want to use the complement? We want to use the complement rule when you know the probability that some event will occur and you want to know the chance it will not occur. Or when calculating the probability of the complement is easier than calculating the probability of the event itself. Okay? Basically, keep an eye out for phrases like at least or less than. Okay, stuff like that is when you may say, oh, I'll just use the complement and life will be easier. Let's take a look at some examples. Let's take a look at an example with 3 parts. Okay, I think I'm good there. Okay. The data in the table represents the income distribution of households in the United States in 2017. So notice it's broken up in various classes. They're all a little different. You have some different sizes. This is a less than 10,000. We had 7,804,000 households had annual income less than 10,000. This is a $5,000 interval. 5,403,000 households had an annual income between 10,000 and 14,999, etc., etc., etc. Okay. Compute the probability that a randomly selected household earned the following incomes in 2017. Letter A, probability of $200,000 or more. Okay, so the probability of greater than or equal to, right? 200,000. Okay, let's first recognize we're gonna need the total. Let's first recognize that the total households we weren't given the information. We got to add them all up. So I'm going to add up these, I think, 10 numbers, and I come up with 120, 63,000. This would be 120 million, but our numbers are in thousands, so this is 120, 63,000. Okay, we could put 3 more zeros and we could get rid of that word thousand. So what's the probability that it is greater than or equal to $200,000 or more? Well, that one's simple. That's simply this number, 8284 divided by the total, 120,063, and this decimal is 0.069. Okay. Now, letter B, less than 200,000. The probability of less than 200,000. Well, we could add up this plus 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 this, and we would get the answer. Okay, we get the answer. That's a lot of work, though. Or we could say, well, it's all of these. We just want to exclude this one. Right? We just want to get, we just want to, this is the complement. It's either those or it's this one, and that gives us everything. So this one is the complement of all those. So we could say, wait a second, this is equal to 1 minus the probability that it's greater than or equal to 200,000. That's a whole lot easier than adding up all of these individual probabilities. In fact, we've already calculated it here. So this is 1 minus 0.069, which gives us 0.931. Okay, letter C. Line up just a touch for you. What's the probability that it is greater than or equal to $10,000? Okay, let's take a look at our chart. Well, again, all of these categories make up the greater than or equal to $10,000. 9 categories. This is the complement. Being less than $10,000 is the complement of all these that are greater than $10,000. So let's use the complement the complement rule and say this is simply 1 minus the probability that is less than $10,000. Okay, so this is 1 minus 7804 divided by 120,063. That goes into a calculator, 0.935. So sometimes it's just easier to use the complement to do the math, and you want to keep an eye out for at least, less than, greater than, etc. to do that.